Okay, let's have a look at creating a fairly simple family. This one is a what's called a hyjoist from the Carter Holt Harvey group. To create this family, you'll be looking at several different areas like total height, thickness, width, all being adjustable, and also one extrusion and one extrusion there and one extrusion there, all held together and all talking together through the properties up here. And we'll go through and create each different type that's available on the hyjoist catalogue, and the end result is that one there. This is a line based family, so when you first go into the project you click your mouse, drag your mouse to where you want it to finish, and that's the length of the joist. So one of the first things to do is to have a look on the net and go off to the CHH Wood Products site, and from there you can download the design brochure, and that design brochure here helps us ascertain, once I get it turned around, helps us ascertain all the different sizes. Like everything to do with Revit, make sure that you've done all your homework first, and that way you're fully equipped to make the family without having to go off and do some other research. So now that we've ascertained all the different sizes, we're ready to go. So back we go to Revit, and we'll start a new family. Revit, new family, and we'll scroll down the options here until we get to metric, generic, line based. We could make this family as a structural model, but then you'll find that it displays quite strangely in certain views and more as a structural beam, and I think in the earlier stages of your projects you may as well stay with just a general generic model, which you can see in all views in the right way all the time and doesn't have many restrictions. So we'll open up this template, see all the other templates here. They've all got parameters assigned to all those templates, which makes things like firearm device a wall hosted item and stuff like that. But this will go anywhere and it's very generic. So we'll open up the family, and the first thing you notice is that you're presented with two reference planes. That intersection of the two reference planes right there, that is the point of insertion. That when you click your mouse to put this item, this family, in your project, that part of the family is what will happen at that exact point in the project. So it's the point of insertion. At the moment we're looking at it in the floor plane, and all we can see there is a reference line. And reference lines, if we have a look in 3D, have got 4 planes to put things on, and also a plane at each end, making a total of 6 planes here. And this length here will be determined by the total length parameter. Now, in order to build a family like this, you have to build a whole set of bones, and you do that out of using reference planes. And before you even make your extrusions out of wood for the flange and the web, you will have created a whole set of bone structure, and all guiding and all flexing themselves correctly. Then you put the skin on the whole bone structure. You'll see what I mean as we go into it, but it's an important concept of families, is that you just create and constrain all the reference planes first, then put your extrusion or whatever it is onto it. So if we have a look from the front elevation, we'll see it's just a line. We've got one reference plane there, and we've got the reference line here, and that is locked to that plane there. And here we have another reference plane, and as I said before, the intersection of these two is the insertion point. We have to make a few more reference planes here, And because we will be making this joist extrude along that way, it means that we will be building it in that plane there. And we will say start there and please extrude that distance. So to do that, we'll go to the left, and that's where we're coming around to, one of the left sides. So if we go to here, we're looking down the length of that. Typical sort of 3D find your way around the model stuff. So let's start putting in a few reference planes to determine what we need. First off, we need a reference plane at the top and at the bottom for overall height. Reference planes you'll find in Create and up here for a reference plane, and we'll just put in an offset of 100 at the moment, and we'll pick line, and we'll pick not the bottom reference level, we'll pick the bottom reference plane. That's important, that, and then we'll click that there. So we've just put that up there. Now we have to pick a reference plane for the thickness of the flange, top and bottom. So we might put an offset in of say 30, and down here again, there and one there. Now we have to start doing some vertical bits as well here. So we'll put in a reference plane offset from there and a reference plane offset from there. We also need to work out what the thickness of our internal web will be. So if we call that a nominal 10 millimeters, we'll put some reference planes there for that. Now we can see the planes that we'll be building everything along, and we can now start to constrain those planes. And the first constraint we'll look at doing, up here in Annotate, use a dimension, come down here, go to the reference plane, dimension from there to there, bring that out to there. Now that's fairly large, so you can always reduce your scale to work with the text looking easier to work with there. That'll be for overall height. The next one we'll look at is the thickness of the flange width, we should say. So up here to annotate, and we'll put one from there to there, and we'll also do what's called an EQ. Now this one we'll control by clicking EQ up there. That turns those to EQ. So as we expand the size of this line and this line will go equally both sides of that centre line. It's a way of keeping the model central. Now web thickness is another thing. So we might move this, go from there to there, and we'll just park that out there. Web thickness we won't be changing, but the flange width we will be. Now we also have to put a couple more in here, which have to do with how far in the extrusion of the web goes into the flanges. So we'll add a couple more. Oh, reference planes, sorry. And we'll put an offset in of 10, and we'll pick that line down there. Put that one in there, and that one in there. And then we will hard set those in to a dimension of 10, and 10, Try to keep things pretty neat as you're putting these in, because these families can get quite complicated, and it's easier to see all your dims if you've got them all lined up, so make them look good. Now we're set, and we can start to build the actual device. I think that there's one more EQ in here that I've missed, but I'll find out what that is, no doubt. Let's start to build now. The flange at the top. Now that'll be the total width of the flange, and the total depth of it will be this here as well. So our flange will fit in this area here. So we'll go to create, and we'll go for an extrusion. And we'll start off with a square basis there. And we'll put that square across there. And we'll put that square across there. Now these flanges do have slightly chamfered corners, so if we use the chamfer tool here, we can put a 3mm radius chamfer on each corner. Just wait till this thing responds again. There we go. So from there to there I'll put 3mm, and from that one to that one I'll put a 3mm, that one to that one, 3mm, and this one to that one, 3mm, same again down here. I could have just made one of these and copied it down to the bottom. But it's a simple piece anyway. Right. Okay. Now, since the web extrudes up and into the flange, we have to cut a hole in the flange, but first off we have to work out how thick that flange is. By my guesstimations and a bit of calculations I worked out, I'll just open up the other family here and see. Oh, well, first off let's constrain all this. So if we go to align, you'll find that we can align to the reference plane, and that's the important thing, the lock. So as you align, in this case multiple alignments of that, click the lock, and that, click the lock, and then align to that, we want that, click the lock, and that, click the lock, take off multiple. To this we want to align that, click the lock, and to this we want to align that, click the lock. Now anywhere these go, this extrusion will follow, and that's the very basis of constraining these families and making them change shape. So if we hit the OK, we now have shapes here, which if we have a look in 3D, and we turn around, oh, hang on, oh, I'm hitting the enter, there we go, there's our extrusion. And we extruded 250mm, and that's our two extrusions. So that's the top and bottom of the flanges. Now let me have a look at the already made up one, and we'll have a look at that, and we'll just see all these. We've got an EQ here. Oh, that's for the flange width, so that's okay. Flange width. Yep, so down here to the left. Overall depth, flange thickness 38. Total flange thickness is 38. Actually it was 37.5. And that's a definite 10mm. Alright, so we'll go back to ours. 37.5 and 10mm. Alright, so we need a constraint here. We want one there, and we want one there. And this 10mm, actually I put in the wrong place. This 10mm goes there to there, and there to there. Okay, let's go back in and edit this extrusion now. What we have to do is create a channel up through here for the web extrusion to travel down. So we'll have to split those lines, and we'll split it there, and we'll split it there. Now let's take a line from there up to there, across and down. Trim that one to that one, and that one to that one. Now down here, same again. There's other ways you could do this, but I'm just taking a very simple way here. Across, across, and down. Go for the trim. That one to that one, that one to that one. Now we have to do our aligning again. So let's go on a multiple alignment and to that reference plane, align that and hit the box, and align that and hit the black padlock. Then to this one, align that and hit the padlock, and align that and hit the padlock. Now take off multiple, and to that, align that and hit the padlock, and to that, align that and hit the padlock. Some more chamfers are needed on those corners there. Oh, not necessary actually, because we can put our extrusion in there. Alright, so that's all configured there. Now, let's create the other extrusion, which will be the web. I'm making it a different extrusion to these two because I want to give it a different colour. But it's made in exactly the same way. All we have to do is go to create, extrusion, and this time make it nice and quick and simple. Take it from there down to there, lock that, lock that, lock that, and lock that, and then that is locked to all those lines there. And while we're here, let's give this extrusion a material property. So we'll go into materials, have a look at some materials, have a look at some timber down here, and for the sake of this we'll call this, I think we've got ply down here somewhere. Okay, we'll call this pine in the middle, plywood finish, say. So double click that to get it into your project, find it here, double click that, that's what it looks like. Click shading to use the render appearance so it uses the colour of it, and hit OK. Now that extrusion we made has received that material as plywood, and we can hit the big tick. Meanwhile, let's go back in and edit that extrusion, and we'll do the same here, but this time we'll go down to another timber value to make it quite a bit obvious and different. We'll call this pine, and that doesn't look much different. So we'll give it pine radiata, which is a much lighter shade, and that'll do there. Then we can hit the tick, and if we have a look at our 3D view, we'll see that we've got two different properties there. This one we forgot to tick our shaded view to receive that colour, so we better edit the extrusion, go down here, go back to the materials and click on that, and now go here, and now we're receiving the colour it should be. So that's our basic one made up. Now we're going to make sure that we can exercise all this and flex it. So let's change a few of these values and get them into what's called parameters, instance parameters or type parameters. There's our type parameters box there. So let's click on that dimension there, and there's one of two ways we can do this. We could say add a parameter up here. As soon as we click on the dimension, up comes the label option, and we can say add a parameter, and this one we will call overall depth. It's a type parameter and it will be grouped under dimensions. Now it gets called that, and you will see that it's come up in the type properties. Now another thing that will change is the flange width, and that's that parameter up there. So let's call that one flange width, and that becomes that now. We wanted 27.5, sorry, it was 37.5, wasn't it, and 10 mil for those. So we'll change that to 10, and we'll change that to 10. This will change to 37.5, and because we're not changing the thickness up here, then we don't really have to give these a label, and we'll change that to 37.5. Now it's rounded it out to 38, but it's really 37.5 in the calcs. Now we've got that strictly obeying those sizes. Those sizes will never change, but what we will change is the overall depth and the flange width here, which is the width across those. This never changes. Oop, hang on, we better change this back to a 10. And that one, 37.5, and the way to do this is to change that to there to 10. That's it there. You sort of get to know your way around these dimensions and which lines to click and then change the dimension. Right, so let's flex this little beauty. A couple of different types are available, and we will call this type, the first type is a 200 high and 45 width on the flange. So we'll call it what the model's called, and it's called HJ 200 45, and the overall depth is 200 and the flange width is 45. Let's hit apply and see what we get. There's our 45 width, there's our overall depth there. So we're sitting pretty, everything's flexing, the web is flexing and staying with those lines there, so it's being pulled up and down. Now we make a new family type, and this type we'll call HJ 240 45 because that's the next size. And of course overall depth is 240, and we'll hit apply and we take it up to there. Now the next one is 240 63, so HJ 240 63, and we'll change flange width to 63 and that's gone out to there. Now the next type is 240/90, so HJ 240/90, and of course we go out to a wider bit there and hit apply, so that's all working. Now our next height is 300, so it'll be HJ 300/45, and the overall depth there is 300 and the flange width is 45. Hit apply. Now we're getting a bit mixed up with our dimensions there, but it's still staying correctly up there. So our next one will be HJ 363. Hit apply. 63. That's it there. And then we had an HJ 390. And we'll change that to 90. Apply. The next size is HJ 360. HJ 360, 63. So overall height goes to 360, width goes to 63, and hit apply. And then the next one will be HJ 360/90. We'll change this one to 90. Hit apply. The very lucky last is HJ 400/90. And height goes to 400, flange width stays on 90, and we're set. So let's zoom out and let's move these up a bit and out of the way of the model itself when it's flexed to its maximum extremities. We may as well lock that. We may as well lock that value. We may as well lock that value, and that value. We'll turn this to shaded so we can see what we're looking at. And there we have it. That's the end of the joist. And that's the length of the joist there. Now there's one more thing we have to do. At the moment this isn't stretching down to that end, and it's not equaling our default length here. Very easy. Go for the align tool, come up here to this reference plane. We want to align both shape handles, the web and the other extrusion. So one, hang on, we'll do that again. Take that one to there. Have a look at our 3D bit. Yeah, see, that hasn't been taken yet. So we've got to make sure that we extrude that along. That's fine. If we go to X-ray mode or wireframe mode, we should be able to see, yeah, that's the other extrusion in there. So we'll align to here, we'll align that little bit, and we'll lock that. And the other one I forgot to do was aligning the large extrusion to the end, like that. Now, whatever length is in here, it will go to. And if we have a look at 3D views, if we go to 1500, it goes that long. Now at this stage, you would save it as a family, and oh, I don't know, I'd just put it in documents at the moment. You save it where you think you should, and I would call it hyjoist, CHH hyjoist, and I'd probably say what sort of family it is because it helps you work that out. And I'd hit the save. Then I would hit load in the project, And oh, I didn't have a project open, so that's interesting. I'll have to open a new project now. I loaded it back into the other family. New project, so we'll do that. Here's a new project opened. We'll go to the ground floor there. Now we'll go to our new one, which will be this one. We'll load it into the project, project 1, load it in, and there it is. And place on work plane, because you're placing it on the ground floor, and then you just simply draw the distance. Have a look at your 3D view, turn on the shaded view, and you have your joist. If you click on it and see the properties, you'll find that there's quite a few different types available in that family. You've got the 245, and here are all the other ones we added. So if we hit 240, 45, we'll see it go up in size. And if we go to the maximum one here, we'll go to HJ 490 and hit the OK, and up she comes to a 490. There's our two different extrusions. They're both living together and they're both going the same length. So there you have it, and you could use that in all your future projects for hyjoists, and you've got all the types now locked in. I made those sizes as type parameters and not as instance, because they are certain sizes put out by Carter Holt Harvey, so you have to know which sizes they supply instead of just making your own. That's why they all became certain sizes. So there you have it. Good luck with it.